Alright, so just going to recap this one just a little bit since I ran out of time right at the end there. But whenever they share a side, you're going to use reflexive property because anything is equal to itself. Okay, but then you can see what's marked as the shared side, the red sides, and the included angles, those blue ones. So that does give us triangle EGH congruent to triangle FHG. And I did one more proof here on this file. Not a lot different than the others in terms of, you just have to take a look at what information you know, and if there's any conclusions we need to make. You just always start out here with your statements and your reasons. And I mean, number one is just always your given information, because that's the starting point. We got to start somewhere. What information do we know that we can start with? And so you start there and mark your diagram. So segment LM is congruent to segment NP. Okay, that's the green one. We also know that LP is congruent to MN, the red one. Okay, so we've got side, side. So I'm thinking either side angle side or side, side, side. Just that's logically what we've got there. And so what happens is this one has the shared side. So the way we put that in a proof, because it has to be in there somewhere, is that PM is congruent to segment PM. When something's congruent to itself, it's that reflexive property. Okay, and now look at the picture. You can see it. It's marked. And I can look in the picture and see side, side, side. Okay, when you're using that, you're using those triangles. So triangle, if I say LMP, might as well just write it the way it's written up here, is congruent to triangle NPM. Side, side, side. Now there's another thing that we can use. Sometimes our end result isn't triangle ABC congruent to triangle XYZ. Sometimes after that we have one more step. So we have this thing called CPCTC. Okay, corresponding parts of congruent triangles are congruent. Way too long to write every single time we need to use it, so we just go with CPCTC. Okay, so if we have congruent triangles, so if I get two triangles in somewhere and I know that they are congruent, then I would know that the corresponding parts of those triangles are congruent. Okay, and we did that with triangle Max and triangle Joe. Okay, and it's just that sometimes, depending on what the proof is asking us to do, we need to use CPCTC. So let me just show you where this comes up in one of these proofs. Okay, so I've got this proof here. We've got the given information. Angle D is congruent to angle F. I've got GE bisects DEF. Okay, so that's one where we have to make a conclusion. That's our given information. So we start here with our given information. Angle D is congruent to angle F. Line segment GE bisects. I see that word bisects, and I am thinking that I'm going to find two equal pieces somewhere. Two pieces that are the same size. Whoops, that should be a 1. Okay. Statement 1 needs reason 1. Okay. So, angle D compared to angle F, that's just a piece of information. I can't really make any conclusion from that, but I can make a conclusion from this bisector. So, if GE bisects angle DEF, that's this whole angle. So this cuts it in half. So that means these two angles are the same size. Okay, again, you're cutting an angle in half, you're going to get two smaller angles. So we need to put that in our proof. Which two pieces are the same size? Angle DEG is congruent to angle FEG. And again, it's because of the bisector. So they're going to say definition of an angle bisector. I'll just use symbols to abbreviate some of those words. Okay, so I've got two pairs of angles on there. Okay. And so now we also have our shared side. So we've got side GE is congruent to side GE. And again, when it's something congruent to itself, it's reflexive property. Now, postulates. We had side, side, side. We had side, angle, side. We had angle, side, angle. We do also have angle, angle, side. If you have two angles on a non-included side, that also works. And so if you look at that, like it's the red angle and green angle, this side is not between them. But that is a valid postulate as well. So I now know that the two triangles, and I'm going to zoom out a little bit here, the two triangles are congruent. So I can say that triangle, if I say DEG, so red angle, green angle over to G is congruent to, so red angle, green angle over to G, FEG, and my reason is the angle, angle, side postulate. But notice this is not the end of the proof because that's not what they're asking us to prove. Okay? And I only, so far in my proof, I have the things that are written. But because now that I know, let's see if it lets me do a little, nope, that's not going to let me highlight that way. Let me do this one. Anyway, it's, what I know is that this triangle is congruent to this triangle. Alright? Well, if those two triangles are congruent, then side DG must be congruent to side FG. And it's like we did with Joe and Max on that other video. Okay? DG must be congruent to FG because they are corresponding parts of congruent triangles. It must be congruent. Okay, so you're not done with your proof until you get to that statement. So we just needed CPCTC on that one. And so let's just do maybe one more of those. Okay, so this one's a fill-in. Okay, some of this stuff is there. Alright, why do I know that BD is perpendicular to? BD is perpendicular to AC because it's given. So some of these, let me double check here. Actually, let me do this one. Alright, let's do this one instead. So JM is congruent to NK. Given. Okay. We also have L is the midpoint, so point L is the midpoint, I'm going to abbreviate, of segment JN and segment KM. That's really a double statement there, okay? But that's the one we're going to make conclusions from. So, if L is the midpoint of JN, so midpoint is a bisector. That's going to mean these two pieces are the same size. So, JL must be congruent to LN. Okay, and also L is the midpoint of KM. So if L is the midpoint of KM, then LM and LK are the same size. Okay, so again, it would just be definition of midpoint. if you have a midpoint, it's good. It's like a bisector for segments. Divides that segment into 2 equal pieces. So that word is like bisector. Now look at the pieces that we have. What we actually have now is that these two triangles are congruent by side, side, side. Alright, so I can write that in here. Oops, yellow's not a very good idea there. I can write that I've got side, side, side on which two triangles? I've got that on triangle, if I say JLM, triangle JLM is congruent to triangle. I started at the one that's between the red and the green, so I got to start with N. L, the vertical angles at L, and then M and K are going to match up, so K there. By side, side, side. I mean, if you want to mark your angle, it's going to be those two, the vertical angles, and then those two. Okay. Now that's not what they asked us to prove. They're asking us to prove angle MJL is congruent to angle KNL. And again, that is just, I just marked it because we knew what we needed to know there. But because I have congruent triangles, I can use corresponding parts of congruent triangles are congruent. So once I know the triangles are congruent, then I know that the parts are congruent. Okay? Angle J in this triangle is congruent to angle N in that triangle. So CPCTC in that box. And that one is pretty much the same there. Okay, so I think that's good for now. We can come back to those if we need to someday.